what's really weird? Right now, you probably know something you should change. Maybe it's your job, your relationship, a habit you hate, or just where you're living. You can see it clearly. The problem's obvious, the solution's right there. But here's the kicker. You're not doing anything about it. And if you're being honest, you kind of hate yourself for it. Welcome to Briefly Science, where we're going to dig into one of the most frustrating paradoxes of being human. Why do we prefer the pain we know over the happiness we don't? Why does your brain actively fight you when you try to improve your life? Because here's the truth that nobody wants to hear. Your brain isn't designed to make you happy. It's designed to keep you alive, and from your brain's perspective, those two things are very, very different. Let's zoom into your skull for a second. About 3 pounds of wrinkly tissue sitting in complete darkness, desperately trying to predict what's going to happen next. That's your brain. And prediction, that's basically its whole job. Every single moment of your life, your brain is running calculations. If I do this, what happens? If that sound means danger, should I run? If I've eaten this food before and didn't get sick, is it safe now? Your brain is constantly building models of reality, testing them against what actually happens, and updating its predictions. This system works because of something neuroscientists call prediction error. When reality matches your brain's prediction, no error, everything's fine, keep doing what you're doing. But when reality surprises you, that's when things get interesting. Imagine you reach for your coffee cup expecting it to be full, but it's empty. That tiny moment of surprise. That's prediction error. Your brain immediately fires up, releases dopamine, and tags that moment as important. Hey, pay attention. Something unexpected just happened. We need to learn from this. Prediction error is how you learn. It's how your brain updates its model of the world. And here's the thing, your brain absolutely hates it. Think about it from an evolutionary perspective. You're a human 50,000 years ago. You've found a grove of berry bushes that haven't killed you yet. You know where the water is. You know which caves are safe. Every successful day reinforces these patterns. Your brain builds this comfortable map of things that keep me alive. Now, someone suggests exploring that valley you've never been to before. New territory, unknown risks, unpredictable outcomes. Your brain's immediate response? Panic. Because uncertainty equals danger. If your brain doesn't know what's around the corner, it can't keep you safe. Studies show that humans would literally rather experience pain, actual physical pain, than uncertainty. Researchers gave people a choice: get a moderate electric shock right now, or maybe get a stronger shock later. Most people chose the certain shock over the uncertain one. Think about that. We'd rather suffer now than maybe suffer later. Your brain prefers a known hell to an unknown heaven. And this isn't a bug, it's a feature. Let's zoom into the machinery that creates this resistance. Deep in your brain, there's a structure called the basal ganglia. This is basically your autopilot system, and it's incredibly good at what it does. The basal ganglia, particularly a region called the dorsolateral striatum, is ground zero for habit formation. When you first learn something new, your prefrontal cortex is working overtime. That's the conscious thinking part of your brain. It's effortful, it's slow, and it burns a lot of energy. But with repetition, something magical happens. Control gradually shifts from your prefrontal cortex to the basal ganglia. The behavior becomes automatic. You stop thinking about it. You just do it. This is why you can drive to work on autopilot and suddenly realize you don't remember the last 10 minutes. Your basal ganglia took over. And from an efficiency standpoint, this is brilliant. Your brain just freed up massive amounts of processing power for other things. Here's where dopamine comes in. Early in learning, dopamine is crucial. Every time you do something and it works out, dopamine neurons fire. They're essentially saying, yes, do that again. This strengthens the connections between neurons, making that behavior more likely to repeat. But here's the fascinating part. As behaviors become habitual, dopamine's role changes. Recent studies found that well-learned habits don't actually need much dopamine to execute. The neural pathways have become so efficient that they run automatically without the need for that reward signal. Your habits are literally carved into your brain's physical structure. And changing them, that requires dismantling these efficient, energy-saving superhighways and building new ones from scratch. Yale neuroscientist Dale Lee ran experiments with monkeys hitting targets for juice rewards. When the outcomes were predictable, the same target always paid out the same way. The monkeys' brain activity in learning centers basically shut down. But when outcomes were uncertain, brain activity exploded. Learning centers lit up like crazy. His conclusion? The brain, as well as the nature of learning, is not fixed, but adapts according to the stability of the environment. When you enter a more novel and volatile environment, this might enhance the tendency for the brain to absorb more information. In other words, your brain literally stops learning when things are predictable. Stability shuts down neuroplasticity. And this is where the comfort zone becomes a trap. Your comfort zone isn't really about comfort. It's about cognitive efficiency. It's your brain's energy-saving mode. Inside your comfort zone, everything's mapped out. Your brain knows what to expect, how to respond, what outcomes to predict. It can run on autopilot. Stepping outside that zone, that's expensive. Your amygdala, the threat detection center, activates. Stress hormones flood your system. Your prefrontal cortex has to work overtime processing new information. Your brain is literally screaming at you. This is dangerous. This is wasteful. Go back to what we know. Recent neuroscience research using fMRI scans shows something fascinating. When people are exposed to uncertainty, their amygdala activity increases dramatically. But more than that, the communication between the amygdala and the prefrontal cortex breaks down. The emotional center overrides the rational center. This is why you can know logically that you should make a change and still not do it. Your rational brain and your emotional brain are in a fight, and emotion wins almost every time. But here's the really important thing, and this is where hope comes in. Your brain can change. It's called neuroplasticity, and it's one of the most important discoveries in neuroscience over the past 50 years. For most of the 20th century, scientists believed the adult brain was basically fixed. You got the brain you had by early adulthood, and that was that. Santiago Ramon y Cajal, the father of neuroscience, literally wrote, "In adult centers, the nerve paths are something fixed, ended, immutable." But he was wrong. Completely, beautifully wrong. We now know that adult brains can reorganize, form new connections, and even generate new neurons in specific regions. People who learned to juggle showed growth in brain areas controlling visual motor coordination. London taxi drivers, who have to memorize thousands of streets, developed larger hippocampi. Musicians who practiced extensively showed expansion in motor cortex areas controlling their fingers. Your brain remains plastic throughout your entire life. But, and this is crucial, meaningful change doesn't happen easily or quickly. Neuroplasticity requires three things: repetition, focused attention, and meaningful engagement. You can't just passively absorb new information. You can't just think about changing. You have to actually do the new behavior repeatedly, with full attention, and it has to matter to you. Studies show that it takes about 66 days on average to form a new habit. But that's just an average. Some habits form in 18 days, others take over 250 days. It depends on complexity, emotional significance, and how often you practice. And here's the really hard truth. During that formation period, your brain will fight you every single day. Because you're burning energy to maintain two systems: the new behavior you're trying to learn and the old behavior that's still sitting there, carved into your neural pathways, ready to activate the moment you get tired or stressed. This is why New Year's resolutions fail. This is why you keep going back to that relationship that doesn't work. This is why that job you hate still has you showing up every Monday. Because change requires sustained discomfort, and your brain's entire evolutionary purpose is to minimize discomfort. So, how do you actually break free? First, understand that the discomfort is the point. When you step outside your comfort zone and feel that anxiety, that stress, that voice screaming, "Go back," that's not a sign you're doing something wrong. That's a sign you're doing something right. Your brain is in learning mode. Neural pathways are being built. Second, start small. Massive changes trigger massive resistance. Your amygdala goes into full panic mode. But tiny changes? Your brain can handle those. Change one small thing, build that pathway, then change another small thing. This is called the marginal gains approach, and it's incredibly effective because it flies under your brain's threat detection radar. Third, create environmental friction for bad habits and remove friction for good ones. Want to stop scrolling social media? Delete the apps. Your brain loves the path of least resistance. Make the old habit harder and the new habit easier. Fourth, use implementation intentions. Don't just say, "I'll exercise more." Say, "When I wake up at 7 a.m., I will put on my running shoes and run for 10 minutes." The specificity gives your brain a clear pathway to automate. Research shows this dramatically increases follow-through rates. And fifth, this might be the most important one, reframe uncertainty from a threat to a learning opportunity. Your brain responds to how you interpret situations. If you see change as dangerous, your amygdala activates. If you see it as exciting, as data gathering, as an experiment, different brain regions activate. Ones associated with curiosity and exploration, rather than fear. Studies on growth mindset show that people who view challenges as opportunities for learning actually show different patterns of brain activity than people who view them as threats. Same situation, different interpretation, completely different neural response. Here's the beautiful paradox. The brain that resists change is also the brain that enables it. The same neuroplasticity that carved your comfort zone into existence can carve new pathways. The same prediction error system that makes uncertainty uncomfortable is also what allows you to learn and adapt. You're not broken, you're not weak, you're just a biological organism with a 3-pound computer that evolved to keep you alive in a dangerous world, now trying to navigate a modern environment where the biggest dangers are boredom, stagnation, and unfulfilled potential. Your brain will always prefer certainty. That's never going to change. But you don't have to let that preference run your life. Every time you step into uncertainty, every time you do something that makes your brain uncomfortable, you're literally rewiring yourself, building new pathways, expanding what's possible, becoming someone different. The person you could be is on the other side of the discomfort. And yeah, getting there is hard. Your brain will fight you. But now you know why. You know about the amygdala, the basal ganglia, the dopamine system, the prediction error signals. You know it's not personal, it's just biology. And biology can be hacked. If this changed how you see your own resistance to change, hit subscribe for Briefly Science. We're unpacking more of the weird, counterintuitive ways your brain actually works. And hey, drop a comment. What's one small change you've been avoiding? What's your brain been keeping you from? I'd love to hear about it. Until next time, maybe try something uncomfortable. Your future self will thank you.